The same group that wrote the previous paper on how ENSO-IOD interactions depend on the El Nino flavor also wrote this paper on how La Nina teleconnection to the Indian Ocean dipole is controlled by the longitude where peak cooling happens. Okay, and there are papers from before which claim that when you do clustering of all El Niños and La Niñas, El Niños show multiple flavors. So extreme El Niños with strong warming on the east and coast, weaker warming towards the dateline called the cold tongue El Niño, extreme El Niño, and then Central Pacific El Niño warming around the dateline. But now this group is, and that paper claimed that La Nina has only one flavor, but this group says there are La Niñas which are more towards the east and center, and some more towards the center and west. So while the prominent influence of El Nino Southern Oscillation on the Indian Ocean dipole is widely recognized, intricate relationships between them are often invoked that introduce challenges into seasonal predictions. Previous studies have shown that different flavors of El Nino exhibit distinct associations with IOD. Here we are calling it La Nina teleconnection to IOD, not interaction. Teleconnection, we mean in the El Nino case a remote influence, not so much a feedback. But here we are not answering whether IOD is independent, whether it's feeding back to La Nina or El Nino and so on. In this study, we demonstrate that La Nina's teleconnection to the IOD is primarily controlled by its longitudinal position. Westward displaced La Nina events tend to produce stronger negative convection anomalies in the Central Pacific and more pronounced Walker circulation anomalies, thereby triggering strong negative IOD events. In contrast, eastward displaced La Nina events are usually accompanied by feeble convection response due to the excessively cold conditions in the cold tongue, yielding insignificant IOD response. The pivotal role of La Nina's longitudinal position on the IOD's response is realistically reproduced by targeted pacemaker experiments providing new insights into interbasin climate connections. Pacemaker experiments are basically where you are taking a coupled model which can produce its own SSTs and SST anomalies, feedbacks, etc. obviously, but you take certain region and put the observational information in there to make sure that rest of the processes follow the observations and you try to avoid model biases in that sense. The plain language summary, we'll read it again also. The tropical Indian Ocean usually witnesses a dipolar pattern of sea surface temperature anomalies, which is commonly referred to as the Indian Ocean dipole in the Indian Ocean side. The IOD phenomenon has received much attention due to its profound global impacts. Not everybody agrees with it. Yet its seasonal prediction remains a large challenge for the climate community. The year-to-year variability of IOD has usually been linked to the El Nino Southern Oscillation, the predominant interannual climate variability in the tropical Pacific. The relationship between El Nino, i.e. the warm phase of ENSO, and the intensity of IOD has been demonstrated in previous studies, which is shown to be dependent on the different El Nino flavors, which is their own paper. In this study, we show that the longitudinal position of negative SST anomalies during La Nina events, i.e. the cold phase of ENSO, in shaping their connection with the IOD, different from the westward displaced La Nina events that can drive robust negative IOD events, so warming in the eastern Indian Ocean. Eastward displaced La Nina events do not yield significant IOD anomalies due to the excessively cold conditions prevalent in the eastern Pacific cold tongue region. We highlight the importance of La Nina's longitudinal position in its teleconnection to other ocean basins and the associated regional climate anomalies. I'm again going to be very brief, but you can see that they are looking at negative SST anomalies and all the La Nina events from 1964 to 2022, and basically argue that there is loading on this side with a large standard deviation and a loading slightly to the the east with this large standard deviation, and the all the events together also have, this is a positional distribution, and this is the amplitude of SST anomalies. You get the idea. And here I will just jump ahead and show some random figures from all the figures they provide. La Nina composite SST anomaly. So this is from observations, warming here, cooling here, opposite of the positive IOD when you have strong cooling here and warming here. And you have Niño 3.4 and dipole mode index. So DMI is here, negative. So this gradient is reversed compared to the positive IOD, and Niño 3.4, and the correlation is relatively low. And in the experiment, La Nina composite anomaly, they are reproducing what they claim is a reasonable representation of reality, and here the correlation is minus 0.15, Niño 3.4 and DMI. Just note that these are negative, so we're talking only about La Niñas. So these are the pacemaker experiments. Basically, you have to look at the models to make sure that model is giving you what you think nature is doing, so that then you can use the model to do mechanistic analysis to understand what terms are contributing to the La Nina IOD teleconnections, or any relation you are looking for in the modeling exercise, right? So DMI, the zonal location and DMI observations. So you are looking at longitude here going from Western Pacific to the Eastern Pacific, and obviously the correlation is high at 0.63 based when you look at DMI and longitude relation. When you look at zonal location, and that's from the observations. So in the observations, the DMI is strongly related to the longitudinal position of La Nina. In zonal location and DMI in the model also has a reasonable correlation at 0.56, and that's the justification for using the model for further analysis. So zonal location and Niño 3.4 in the observations. This is Niño 3.4 and zonal location. Obviously, the correlation is low, but if you look at in the experiment, that's also low. In other words, the scatter plot of longitudinal position of La Nina against DMI during autumn, and scatter plot C is scatter plot of position of La Nina against its amplitude as Niño 3.4 index. So the amplitude of the La Nina itself is not related to where it is maximum. It can be similar amplitude and be more towards the east or more towards the west center. So pacemaker experiment is reproducing this relation, this lack of relation, let's say, between the zonal location and the amplitude. Jumping ahead to the mechanistic explanations, when you have a La Nina that's westward, so you can see that weaker amplitude here, stronger cooling here, and you have, of course, the warmer anomaly here, colder anomaly here, and you look at the sinking motion associated with the Walker cell anomaly or cold SSTs, and the positive rainfall, crunched warm pool, warmer warm pool, rising motion, etc. here, and you have wind anomalies, vertical circulation anomalies, etc. here, but this is relatively weak. Whereas if you have eastward La Nina, you have stronger response on this side and broader response over the Indo-Pacific, and you can see this anomaly here is stronger and this anomaly here is weaker. Well, let's make this is westward La Nina in the experiment, observations, experiments, eastward La Nina, and observations and experiments. So you get the idea that when La Nina is westward, amplitudes need not be larger. You can see they are similar amplitude both in the experiment and in the observations, but the correlation or teleconnection, as they call, to the IOD is stronger in this case. Okay, so jumping ahead to some conclusions, it's noted that the ENSO exhibits pronounced asymmetry in its impact on the IOD. Our previous study has shown in that Our previous study has shown that the different flavors of El Nino, i.e. the EP and CP El Ninos, exhibit distinct relationship with IOD, which I discussed in the previous podcast. But here, note that they are saying ENSO impacts on IOD. They are not saying IOD is independent. In contrast, the observed La Nina's teleconnection to the IOD is mainly linked to its longitudinal position. The intensity of the eastward displaced La Nina events has no significant correlation with the IOD amplitude. That's what this is, right? Weak IODs and hardly any correlation. Okay, the intensity of the eastward displaced La Nina events has no significant correlation with the IOD amplitude, unlike the eastward displaced El Nino events that show a high correlation between its intensity and that of IOD. Very humid and hot here in Kanpur. Positive SST anomalies superimposed on a background cold tongue SST can potentially lead to obvious convection changes when the total SST is above the convection threshold, which is around 28 degrees C. However, negative SST anomalies result in feeble convection response due to the excessively cold conditions in the cold tongue, which is what they imply here. And the complicated relationship between ENSO and IOD makes it challenging to achieve a skillful seasonal prediction in the tropical Indian Ocean region by utilizing the tropical Pacific information. How to translate the identified physical linkages between climate modes into operational forecast skill deserves future investigation. They always say these things, but again, I should remind you that when we have a general circulation model, it's obviously doing everything together. So the key question then becomes whether models are able to do the different flavors of El Nino and La Nina, and whether they're able to do the correlation with IOD without worrying about IOD is independent or not. If we can reproduce their covariability in all their flavors, then we can assume that the model is also capturing the teleconnections of this situation, El Nino IOD, La Nina IOD, and so on. Not necessarily so, because Walker cell is one thing, then there is the Hadley cell. Models can have biases in all sorts of directions because convection is very difficult to do. Nonetheless, skillful predictions because of these relations is kind of a statement you have to take with a bit of pinch of salt. Okay, see you in the next topic.